Welcome to Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada, at my desk doing some hardware. Got two projects I was working on this weekend, so I thought I'd show them off. So maybe first up, let's go to the overhead. I'll talk about how I'm working on this camera tester. So I'm writing the tester for the MEMENTO camera. It's kind of our all-in-one little camera board with the ESP32S3 and a TFT display and like buttons and just a lot of hardware. And one of the things we got to do before we ship it is I have to program it with codes. This is it with a preview screen. Hi. I gotta have all the boards tested. I had to test the LED plate, and the LED plate tester I actually did already, and that was really easy. I just used, hold on, this cable is like totally woven into everything else. If you have cables, they're always all over the place. Okay, so I'm pretty sure this is still programmed with the tester. Yes. So this is the tester for the LED ring, which is a separate board, like it's completely disconnected. And all it does is show red, green, blue, and white. If all the LEDs light up, then you know it's working. So it's really easy. It's a visual test, and I just used a Pico for that. I've kind of been changing all my testers to use Picos because they're pretty durable. They have a lot more memory than Arduino Uno, and another thing I really like about them is the bootloader is built into the ROM. So what I do is I make the first tester for every board, and then there's people on the fabrication team, and I say, here's how you make the tester, and here's the code. And it's easier if I can give them a UF2 because you don't have to use like AVR dude to burn in a hex file. I mean, they can do it, but it's like, I just think UF2s are way easier. This tester was really easy. It only took me 5 minutes. But then the next tester I have to do is for the camera itself. So the first thing is I use one of our Pico Brains boards. Actually, this board was originally here. So use a Pico Brains board, and I store the firmware in Flash or on the SD card. And then I program the board through this like adapter plate. So that, this brain board is the same every time, and this adapter changes. And you can see this one is like, it says MEMENTO on it. And the way this works is I've got these test pads here for reset, and this is the boot pin. And that's how you get into the ROM bootloader on the ESP32S3. And then here hidden under the TFT are two RX TX pads. And what's interesting is, I was originally making these testers and I was bootloading them over USB. So I'd actually use the ROM bootloader with like USB serial, and I would use that to program. But actually is a little bit faster to do UART RxTX, even though like USB is like, 12 megabits per second. So it's like 1.5, uh, 12 megabit. And this would be, you know, 2 megabits, I think is kind of the fastest that you can do, maybe 3 megabits, but it ends up actually being a little bit faster, probably because of like delays and encoding and packetization and stuff. So, and it's also just a little bit more, I don't say durable, but less flaky. Like sometimes USB uploads fail, but I've never had a failure with the UART bootloader. So, you'd press this onto here, and then the pogo pins make contact with the, let's see, autofocus. You can kind of see they make contact with the pads, and that's how we do the programming. So what I have to do is I have to write the test program. And one thing that I've done recently that saved me a lot of time and programming and like effort in distributing factory test firmware is the code that's used to test the board, and the code that the test, like the shipping demo, is actually the same example. And then I have like a flag. I have a way of detecting whether it's being tested, or you enter test mode. And if you're telling it enter test mode, the factory code will like go into test mode and do the test. And that way I only have to burn one code in. I have to like burn one binary file in, and that binary file, I said, like I said, I send it like a UART command to say, hey, I'm going to put you in test mode. I do the test, and then when the customer gets it, it boots up into the factory demo, and they don't even know about the test code. And like everything we write is open source, so it's not like, ooh, like I have to keep it a secret. Like if you really wanted to, you could like put it into test mode by sending it the hex code AF. That's usually what I do to signal it's time to do test. But like, I don't, it's not a secret, and it's all good. So I've been writing the test codes. If you go to the computer, I'm writing the test code with Platform IO, and the reason I'm using Platform IO is it's just very like lots of revisions, update. I have to like I'm constantly like tweaking the tester and adjusting it and making it like, okay, what can I test first, and how do I optimize it? And so there's a lot of recompilation, and Arduino IDE is just not as fast as Platform IO. I will eventually have this compiled in Arduino because I wanted to include the bootloader, and Platform IO doesn't, and I can't quite figure out why. Et cetera, et cetera. There's good reason for me to make sure it compiles an Arduino IDE, but to start, I'm just testing it with Platform IO. And so right now I just have a Boolean that tests whether it's testing. And then just as I'm like done with the test, like finish the test program, that's when I set this variable to false. And then I'll have like something that reads the UART or the USB, and like, oh, if it's connected and it says something, put it to test mode. So another trick I do when I do test mode, especially for testing complicated boards, is I have this repetitive loop that tests over and over again, because sometimes like a test will fail because of just some timing, or you'll see like I have a microphone speaker test or an accelerometer test, and if somebody's holding it off, I don't want it to just fail. It should retry a couple times because it's probably okay. Just something jittered it, or like a pogo maybe didn't make contact for a split second, or like they had just placed it or whatever. So I have, I try to chunk off the test into sections of like, I'm testing this element at a time. For example, I test the accelerometer, and there's a couple tests I perform. And then once it passes that test, I set this global flag. It says, test that part has been completely tested correctly. I don't need to do it again. And that way it just cleans up the output, because that way I don't have to see all this like, okay, this passed. I just want to see what failed. So if we're testing, I have the display shows the test as well as the serial monitor. So if you go to the overhead real fast, I'll just show the test program. So this is the test program. So for example, in this case, the accelerometer failed. The accelerometer says failed because it needs to be level, and I'm holding it at tilt right now. And so, if I tilt it forward, hold on, I'll turn it off. It stops at the speaker microphone test. One of the other things I try to do is if I can get like two things to test each other, that's kind of handy. So often I'll have like a NeoPixel that's tested by a light sensor. Or in this case, there's a speaker, and over here there's a microphone. And so I have the speaker make a loud sound, and then the mic picks up the sound. I'm still tweaking the numbers a little bit, because like each board has a slightly different speaker volume or a microphone response rate. So I have to just like tweak the numbers to get them to run nicely. But you can see, maybe there you go. So now once it passes the mic speaker test, you can see it's tested like the SD card. Actually, I'll show if I remove the SD card. It first verifies if the SD card is inserted. And that actually tests the IO expander as well, because that goes to the IO expander. And then, and then what's nice is that I can remove the SD card, and it's like, it's already tested, so it doesn't test it again. And then the final test is, it's like, okay, press the buttons. So in the back, there's the GPIO buttons. And so as you press each one, they turn green to let you know. And then the shutter button is last. And then it will go into camera mode, although I think, hold on. Let me try again. I think removing the SD card made it upset. Okay, so pressing the buttons. Yeah, and then it'll go into camera mode. And then, this is the final test, because if you see yourself or whatever, if you see something on the screen and you wave your hand in front and it shows up on the TFT, then the camera works. and the display fully works. And now the board has basically passed tests and everything. For the camera to work, all the power supplies have to be good. All these GPIO have to be good. Like the camera's not going to work if any one of the GPIOs isn't working because it does. Is that true? No, I think I actually have to do a color bar test also, and then I'll check that all the colors appear. Another thing I can do is have it send me a JPEG. I don't think this is a JPEG, but maybe it is. But if you send me a JPEG and it decodes, that means that the full 8-bit interface is working. And then the buttons have been tested, the microphone, the piezo. So that's it. I mean, that's kind of my test procedure. And then this is also, by the way, this camera mirror thing is also the factory demo, like when you get it. It says here, I don't know if you can read it, but it says battery 6.6 volts. And the reason it does that is actually I've messed with the camera gain / resolution. I have to the ADC gain for the microphone. I have to reset that before I pop into camera mode. So a couple things remaining. But otherwise, this is pretty good. I think it takes a couple hours to write the test. But I like it. Okay, so the next step, I'm still working on this ICN board. Let me put this away. I'm gonna turn this off so it doesn't beep. So I've got this. It's such a mess here. I've got this ICN board. So we were working on this ICN breakout for the ICN6211, and this is actually working great. But now I actually am trying to kind of revive this project where I have these screens that I bought that are 4-inch 800 by 480, and I wanted to turn them into like a Pi TFT hat. So this is an ICN. This is the DSI connector, and then this cable goes over here. I removed it just so you can see the wiring. But it's not working, which is why it's in pieces. And I'm not sure why. And one of the things that is a little tough is, if you guys remember a couple weeks ago, I was showing off you can test, I've got this ICN hooked up to this display. And because this round display uses the ST7701S, which is like a really nice chip that I like and I'm friends with, you can send all pixel on, all pixel off command modes to that display, and it will at least tell you that the SPI interface is working. But this chip, if you go to the computer, is a ER61408. Who freaking knows? It's some Renaissance chip, which I've never used before. And I'm sure it's wonderful, but it doesn't have that command. You see, it says enter invert mode 21, but then it doesn't have 22 and 23, which is the all pixels on. And so I was like, oh, well, maybe I'll enter and exit invert mode and I'll see the pixels change, but that actually wasn't working either. And then I have this other setup with, be careful. Maybe I'll move the overhead rather than moving the board. Okay, so can you go to the overhead and then okay, it's a little, I'll wash this out. So here I've got, actually, no, this is not wired up to this. This is a hat, and you can see it's working. And this one has a, this is using DPI, and it's got a SAMD, there you go, a SAMD09 on it. And so I was able to reprogram and test the board with the SAMD21 to send the initialization commands to here. But the display doesn't turn, the invert mode only works if it's getting a valid VSync, HSync, dot clock signal, which is really annoying because that's the thing that's not working. Like if it was working, I wouldn't need to test it, but it's not working. And I think that either it's sensitive, maybe the HSync isn't good enough, maybe it's 40 hertz, it should be 60 hertz exactly. Or maybe something is configured, I don't know, maybe the ICN is generating 800 by 480 instead of 480 by 800. I don't know exactly what the deal is. Or bit dot clock isn't quite right. And so I'm not stuck. I know what to do next. But it's challenging because I don't know on this board here, what is broken? Is it the AT-Tiny sending the SPI commands? Like, I think it's working. Like, I see this display flickering. Or is it the ICN not sending correct data for the color bar test? So, you know, the one good thing about TTL displays is that they are like very basic in that it doesn't matter what's being sent on the RGB and RGB lines. Like there's no like knowledge about those. All that really matters is that the H-Sync, V-Sync, data enable, and pixel clock are correct. And so, I don't know if like you can see, but really close up, I don't know how close oh, I can get pretty close. Okay, close up, and then I'm gonna autofocus. And I'm gonna go plus, 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 plus. So what I did is I removed here, this had a 402 times 4 resistor pack, which is used to just reduce a little bit of ringing. And I removed it and I'm soldering directly to it so I can pipe my own VSync, HSync data enable and pixel clock. And then this data, you know, this is definitely, there's like signal, it's twiddling, but if the chip is upset because the data isn't coming in the exact right clock speed or the right synchronization or whatever, in theory, if I pipe in this from that working display that I know works from the Raspberry Pi, like the Raspberry Pi is generating correct H-Sync, V-Sync data enable and clock, it should work, but it's still not working. So I don't know. Hopefully by next week, I mean, it's one of those things like once it works, they'll all come together, but it's like, I don't know where the broken thing is. But that leads me into the great search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her power of engineering to help you. Yes, you find the things that you want and need on digikey.com. Thank you, DigiKey. Ladyada, what is the Great Search of the week?
Okay, so if you go to the overhead back, I was just talking about how I'm trying to debug this board and I'm having some failures with these signals. The display isn't recognizing these synchronization signals as correct, and I don't know why. And I'm in a SNIT, and so I removed one of these resistor packs in order to get directly to that data, so I can pipe in known working data, and at least I can remove one pin at a time until like magically works. I don't know. And to do that, I soldered these wires on, and I was like, oh, you know, I've never covered wire wrap wire, which could be really, really handy. This is Kynar wire wrap wire. Hold on. Oh my God, this is so close. And this 30 gauge solid core wire with, it's called Kynar sometimes, coating. I use it all the time for debugging and hot wire fixing boards. Sometimes it's called blue wire because people tend to use the blue wire for wire wrap hacks. Very, very common. I definitely recommend if you're doing PCB design to have some of these because you can see quite small pads. You know, if you're using like 8 or 10 mil wools, you could definitely use this wire. So let's go to my computer and go to DigiKey. Another option, because it's like we're just typing in wire wrap into DigiKey, a little boring. You can also use magnetic wire, and this is from Elm Chan, who like somehow has written all code that everyone uses for electronics everywhere. Really cool person. I hope one day to meet them. So they've made some beautiful designs and they use magnet wire. And magnet wire is also a very thin wire. I'll say one thing that's nice about magnet wire is that the enamel on it, you can see the enamel is what makes it non-conductive. It's often used for coils, so it needs to be coiled up, and then the enamel keeps it from conducting. But it's very, very thin. You can get it much thinner than wire wrap wire, and you don't have that cover that might get in the way. But on the other hand, there's the risk that if you nick it, it will conduct. So it's risky. It's like more advanced because it's riskier. But it allows you to do like really complicated boards. Like this one you see is a mix of SOIC, looks like, you know, DFN and TQFPs. So pretty cool stuff. So let's go to, actually, let's go to Wikipedia and I'll talk about wire wrap. So wire wrap wire was originally used for wire wrapping around these pins that were used to create PCBs. And this was how you did point-to-point wiring before printed circuit boards were basically like $2 a piece. They used to be virtually impossible for people to get, very, very expensive. And so students would use, or even engineers would use wire wrap wire, and they would have these posts that they would wrap using a wire wrapping tool. Oh, actually, sorry, this is not, I don't know if they have the tool here. Yeah, wire wrapping tool. And so this, the wire would snake in, and then you twist it, and it would make this perfect tight wrap, and it would be like a cold weld. It would be a good soldering connection without soldering. And you could undo it, and you could, with colored wires, you could trace it around, and you could of course make these complicated 3D shapes. So wire wrap wire, you know, which is wire, has its own category. So let's look at what is available. So it's like 99, which doesn't seem like a lot, but it's like, there's not a lot of variation in it. So let's look at active and only stocked at in stock. So just get rid of all the other ones. So the wire gauge. 24 gauge seems really thick. I think that would actually be used for like wire wrapping power connections. For PCB hacking, 30 gauge is plenty. It's more than enough. Next up, what color? Basically, everyone goes with blue. I'll say that there's one interesting thing. So there's two jackets available. There's PVDF, like, you know, PVC. And that's what I use, and it's perfectly fine. You could also get tetrafluoro, which like Teflon, I think, is what it's sometimes called. And these are going to, ETFE is going to be more expensive, significantly. Like, you know, this is 100 feet, and it's like $40 instead of, you know, $10. This doesn't have as much temperature. It's less, it's more resistant to temperature variation. And I believe that when you solder, you know, you solder the tip of the wire, the jacketing doesn't pull away because it's more resistant. However, having worked with Teflon wire, it's a total pain in the ass to strip with wire strippers. So it's like, you have to have it like really good quality wire strippers. You can't just kind of, oh, like it's close enough and I'm just yanking. It's not, if you just, you have to like really cut through and yank rather than just sort of pulling the jacketing off. So, you know, if you absolutely need the temperature resistance, go for it. And then, you know, you could go by price. You know, we have a roll you can get. Jonard has multiple different colors available, kind of like these photos, red, yellow, green. Honestly, a lot of people do blue. But one thing I thought was interesting, oh, this is interesting, you can just get like little strips, is that there was a version, because I was like looking at this and I was like, what do you mean with dispenser? So if I had to do it, first off, there's this cool like 5-wire color kit, which I would recommend if you're like going to be doing a lot of wiring and repair. It's a little bit more, it's like $85, you get a lot. But this is definitely cool. So one thing that is really annoying about wire wrap wire is you buy a spool of a couple 100 feet, but you're never going to get to use it because it gets like knotted so quickly because it's like you're pulling in and it twists around itself. And then it comes off and then you wrap it. And then when you rewrap it, it gets tangled. You can get them with dispensers, which I did not know. If I was going to start my life over again with all the knowledge I have, which is like, it's like a meme, I would get wire wrap wire with the dispenser. So this is what I recommend. Not just a spool, get it in this casing. You'll actually get to use the whole thing. So this is my pick for the great search.
That's great search.
Where in the world is that part I need? The great search with DigiKey.
Alrighty, thank you so much, everybody.
Thanks, everybody.
Here in the background, we have a little engineer here who wants to
She wants,
be fed, and then
she
get
wants
to
my
bed.
attention. Yeah, yeah.
So thanks for joining us.
Thank you,
tonight.
guys.
We'll see everybody throughout the week. We have a bunch of shows, new products, and more. And thank you so much for spending your Sunday night with us. We'll see you next week.
Bye, everybody.